Welcome back to another statistics question paper. Here today we are going to solve May June 2016 paper 7. So as you can see from the question, we're given that the time taken for a particular type of paint to dry was measured for a sample of 150 randomly chosen points on a wall. So first what we will do is we'll let x, so we'll let x be the time taken. So here x is the random variable here. It's the time taken here. And these are measured in minutes. So this is a time taken measured in minutes, and it's important to note down the units because in the real world application you'll have to know the units. The units become really important. So we're given from the question that x has a normal distribution where the mean is 192.4 and the variance is 43.6. Now, if we are looking at the distribution for the mean, then we know that for a given sample of 150, the mean is normally distributed with the mean being the same and the variance being divided by 150. So in this question, we have to find the 98% confidence interval for the mean drying time. So what does 98% confidence interval mean? Let's look at it. The 98% confidence interval implies that this shaded region represents 98% of the data. So 98% of the data, 90% of the data is being represented here. So if this is 98%, so C minus and C plus is the confidence interval. So these two numbers, C minus and C plus, will be the confidence interval. Now as you can see, if this is 98% here, so by symmetry we know that this has to be 1% and 1%, right? Because 98 plus 2% gives you 100%. Now the only problem here is to find these two values. So how do we do it? So as you can see from this writing here, probability of mean is less than C plus. So what I'm basically doing is all the values that are less than C. So all the values that are less than C also includes this unshaded part, right? And this shaded part. So this shaded part is 98% and this is 1%. So the total is 99%, so that's why the probability is 0.99. Now, if you standardize it, because whenever we are solving a normal distribution question, standardizing is must. So if we standardize this, or let's say we are standardizing. So we're standardizing. So when you standardize, your x variable goes to z variable because z is a standard notation for the standard normal distribution. So this is the formula that we have to use, that's C plus minus mean over the standard deviation. So in this case the standard deviation is simply the root of this here because this is the variance. So this is equals to 0.99. So if you solve for this, if you solve for this here, you basically get this here. Okay, now how did we get from this to this? Okay, because this is just the inverse formula, right? Inverse normal distribution. Here we know the area. So if you do an inverse normal distribution, you'll basically get this one. Or in other words, probability of z less than 2.326 is 0.99. So when we compare both sides, so this quantity has to equal to this quantity, right? So when we equate that quantity, we basically have C plus equals to this, and C minus equals to this. Okay, so if you look at this point here, if you follow these calculations from here directly, you will get C plus, right? You'll get C plus. But how did we get C minus here? Okay, so how did we get this C minus here? So it's very simple. If you look at this diagram here, so let's say the gap between C plus and mu is delta. Okay, like the gap is delta. So because we have C plus and mu, right, this is the mu, 192.4, and C plus is just the value that we just found out, right? So the C plus value is 193.65. So when we subtract this with the mean, we basically get delta. So again, C minus is just mu minus delta. C minus equals to mu minus delta. So if you just subtract 192.4 and 193.65, you get 191.14. Hence the confidence interval is 191 and 194 into a significant figure. Okay, so now let's move on to the next question.